Hi guys, it's Mrs. Tucker. I'm going to try to put together here another video review. This will be for review 2, the second 9 weeks review for the common assessment. Okay, here's the second review. Let's start off with number 1. I may not get this whole thing done, but I'm going to send you out the first piece anyway, and eventually I'll finish this all up. You guys know that I go pretty fast through the reviews when it's a video review because you can pause at any point you want to. You can rewind as many times as you want to. And I may not work the whole thing out for you. You got to do some of the work too, but I'll push you in the right direction. So here we go. Number 1, similar figures. The pair of polygons is similar. Did you know that the symbol for similar is this right here? Yeah, that's a lot quicker to write than the word similar. Write a proportion to find the missing measure, then solve. Here's my small, here's my big rectangle, and they're both similar. So I think I'm going to compare my small to my big, and I want to compare corresponding lengths. And I'm going to set up a proportion. Pick a length in the small, any length in the small. How about if we pick x? X in the small corresponds to what in the big? Well, that length right there is what? Yeah, 21, because it's a rectangle. Go back to the small. 17 in the small corresponds to what number in the big? Well, it's got to be 45 because it's a rectangle. So there's your proportion, and you've got it set up. Write a proportion, and we did. Now cross multiply and solve for x. And I know you know how to do this. I'm not going to do it for you. All right, there is an answer bank. When you get an answer for x, check and make sure that it's correct or that you can find it. And when I look at this, I know that 21 is smaller than 45. So my answer had better be smaller than what? Yeah, it better be smaller than 16. And that's about, 21 is about half of 45. So my answer over here is going to be about half of 17. Okay, it's going to be, you know, half of 16 is 8, half of 18 is 9. It's going to be somewhere between 8 and 9 maybe. All right. Let's look at number 2. Determine whether the pair of polygons is similar. Explain why or why not. If they are similar, side lengths are what? If they are similar, side lengths are proportional. So I'm going to compare small to big again. Pick a length in the small, any length in the small. 3 in the small corresponds to 6 in the big. Pick another length in the small. 4 in the small corresponds to 8 in the big. I'm going to look at cross products. That's 24. That's 24. It looks like they're proportional. You know, if you even look at the numbers, don't you take 3 multiplied by 2, you get 6. 4 multiplied by 2 gives you 8. 5.5 multiplied by 2 gives you 11. You have a scale factor that's equal to 2 going in that direction. There's another reason why you can say, yes, they're similar, because the big triangle has side lengths that are twice the smaller. Or you could say the smaller has side lengths that are half the larger, right? Okay, or you could say your cross products are equal. Side lengths are proportional. The next one, number 3, determine whether this pair of triangles are similar. Do the same thing. Compare big to small or small to big, or however your teacher told you to set up a proportion. Pop your numbers in. 6 corresponds to what in the big? Pick another length in the small, put it here, pick another length in the big, put it here. Check your cross products. If your cross products are equal, it's proportional. If they're not proportional, meaning they wouldn't be similar. This pair of polygons is similar. Write a proportion for the missing side, then solve. Small to big. Let's see, where is the missing side? It's right there, and it's in the small. So x in the small corresponds to what length in the big? Yeah, it's the same as the 6. Pick another length in the small. I'm going to avoid the decimal. Let's pick 2 in the small. Corresponds to what in the big? Yeah. Now you're going to cross multiply to solve for x. Number 5. The rectangles below are similar. Find the perimeter of the larger rectangle. And they sure don't give you much to go off of here, do they? No, they really don't. If this side length over here is 2, then I know this side length over here has to be what? Yep, that has to be 2. And 2 plus 2 is 4. You know, perimeter is the distance all the way around. 2 plus 2 is 4. So of the perimeter of 16, 4 of it is these two sides here. 16 subtract 4 gives you 12, and that's the amount that's left over for this side plus this side. And if they're the same length, what plus what length plus itself gives you 12? Okay, this has to be 6 and this has to be 6. 6 plus 6 is 12. This makes 13, 14, 15, 16. You know, if you want to work the problem this way to calculate the new perimeter, you can. Now you can set up a proportion to find this length here. You could say small to big. 2 in the small corresponds to x in the big. 6 in the small corresponds to 12.5 in the big. You could cross multiply, solve for your x, get your perimeter that way. Also, there's another way you can approach this. The perimeter over here, and we'll call that perimeter small, multiplied by your scale factor gives you the perimeter of your big, because perimeters are also proportional. So maybe you want to try it both ways. Do it this way and do it this way. Question is, how do you find the scale factor? Scale factor equals your new length divided by your original. And if you're going this direction, this is your new and this is your original. I think you ought to work it out both ways and see if you don't get the same perimeter. Okay, give it a try. I'm going to ask you Monday, did you get the same perimeter working it both ways? Number 6, what's the distance between the two docks? I have a dock here and a dock here, and I want to know D. Anytime you have a system that's set up like this and they don't tell you, you know that they're similar. I've got a right angle here and a right angle here. The little triangle, my small triangle, is similar to my big triangle. You just have to set up a proportion. Small to big. D is in the big. That corresponds to what length in the small? Yeah, that's going to be 104 feet. Pick another length in the big. That's 114 feet. Corresponds to what in the small? Yeah. I want to see you guys set up this word ratio every time. It tells you where to put your numbers. Now you're going to cross multiply and solve for D. Number 7, a road sign casts a shadow that's 4 feet long. Here's the sun rays right here. At the same time of day, a 6-foot tall man, here's my man, he's 6 foot tall, is standing next to the sign. He casts a shadow that's 2.4 feet long. And here's the sun rays. How tall is the sign? Anytime you're using the sun's rays to set up triangles, they're going to be similar. Draw yourself a diagram, set yourself up a word ratio. Okay? X is in the big. That corresponds to what in the small? Yep. Go back to the big, 4 in the big. Corresponds to what in the small? Cross multiply to solve. And then you'll have how tall the street sign is. All right, if the distance from B to E is 32. B to E, all the way across here. The distance all the way across is 32 meters. And the distance from B to C is 19.2 meters. From here to here is 19.2 meters. Find the distance from C to D. They want to know this distance here, C to D. All right? Well, on our last retest, a lot of you guys got this problem wrong. And you will see this on the STAR test. I see two triangles and they're both similar. They are both similar. I see a small triangle here, and I'm going to draw it out here so you can see it. Here is D, here's point C, and here's point E. And here is X, that's the distance we're trying to find. Then there's the large triangle, and that's the other triangle that's similar. This here, and this here. So I'm going to draw a large triangle. This is point A, B, and E. This distance from A to B is 22 meters. The distance from B to E all the way across is 32. I need to know this distance from C to E. I need to know this distance from here to here. They didn't give it to me, but I can calculate it. The entire distance from here to here is 32, and I know the piece from here to here is 19.2. Can you calculate the distance from C to E? It's going to be 32.0, subtract the 19.2, and this is the piece that you guys got wrong on the last retest. Subtract that out. Whatever distance you get right here is the distance that goes right here, and that's what you use to set up your proportion, not the 19.2. If you do small to big, X is in the small. That corresponds to what length in the big? Go back to the small. What's this distance here? It's the difference between 32, this distance here, and this little piece of 19.2. So whatever you got right here goes in for the small. Right here. Whatever got right there goes in right there. What's the corresponding length in the big? This one corresponds to what in the big? Okay? That's how you work that one. The big mistake everyone made on the retest was they used 19.2 right there, and that's not this length here. 19.2 is not this length right here. Number 9. Triangle RST is similar to triangle XYZ. Do you see XYZ here? Yes. Do you see RST? No. They're similar. They didn't give us RST. You need to draw it. And I don't know if it's going to be bigger or smaller, but I'm going to make them look kind of the same shape. X is this point here, so R has to be this point here. Y is this point here, so S has to be this point here, and T goes here. It says if the perimeter of triangle RST is 11.25 inches, determine the length of ST from here to here. Hint, draw and label triangle RST. One of the things you guys were supposed to learn was that perimeters are also proportional to side lengths if the triangles or if the figures are similar. What do I need to do over here? I've got this side, and this side. I'm talking perimeter over here. You better be thinking I'm going to calculate what over here. Yeah, I'm calculating the perimeter. It's 10 plus 7 plus 5.5. Add that up. You're going to use those perimeters. And this is definitely going to be your big triangle, isn't it? And this is going to be your small triangle. You're going to set up a proportion Say small to big. Okay, got cut off there. I'm going to finish the video here. All right. Not only are your side lengths proportional, but so are the perimeters. So pick your perimeter for the big, whatever number you got here, that goes here. Perimeter big. Perimeter small is 11.25. Okay? The side that we're trying to solve for is this one right here, and that's in the small, so that goes here. The corresponding side length to x is what in the big? It's 5.5. Once you figure out your perimeter big, then you can cross multiply to solve. All right? I know you guys have seen this one over and over and over again, and you're going to keep seeing it till you get it right. All right? We won't give up on you. Number 10. For question 5, I don't think that has anything to do with anything here. It says a scale on a map is 1 inches is the same as 575 miles. Find the actual distance for each map distance. This is your map distance. This is your map distance. This is your actual distance. Each inch on the map is the same as 575 miles of actual driving actual distance, not necessarily driving. This right here, is that actual distance out there in the real world, or is that on the map? Yeah, that's map. So put 3 1/4 here, and x goes down here. Convert to a decimal if you need to, cross multiply to solve. That's how a scale on a map works. Number 11, find the scale factor from the large rectangle to the small rectangle. If the two rectangles are similar. Oh, if they're similar. They're not telling us they're similar. We're going to have to prove that they're similar. All right, and you can prove that they're similar by setting up a what? Yeah, we can prove by setting up a proportion and showing that the cross products are equal. I'm going to pick 12 in the big. That corresponds to what in the small? This length right here is, yep, that's 10. 24 in the big corresponds to what in the small? Okay. Cross multiply. 10 times 24 is 240. 12 times 20 is 240. Because my cross products are equal, I've just proved that the two rectangles are similar. Okay, now that I've proven that the two rectangles are similar, they want me to calculate the scale factor. You guys just have to remember that the scale factor is a new length divided by the corresponding original length. And I'm going to pick numbers that look the easiest. Okay, if I went from the larger to the smaller, which one's your new? I went from the larger to the smaller. That makes this one my new rectangle, and this one's my original. The original was dilated to make the new one a little bit smaller. So pick a length in the new. I'm going to pick 10 in the new. Corresponds to what in the original? This length right here is, yep, and now you're going to reduce. And when you reduce, you'll have your final answer. All right, number 12. This will get you halfway through the review. Okay, I'm hoping you can do the other half on your own. Maybe I'll do a second part of the review, the second half later. Number 12, regular hexagon. CDEFG is dilated using a scale factor of 1/2. What is the length of each side of the dilated hexagon? Regular means that each one of the side lengths is the same. So this is 6.3, 6.3, 6.3, 6.3, 6.3, 6.3. You guys know I just said scale factor is new divided by original. How do you undo division by the original? You multiply both sides by the original. That's how you get rid of division by original. If I multiply this side by original, I get the original length multiplied by the scale factor equals the new. Okay, I know Miss Bailey does a little triangle thing. Your original multiplied by your scale factor gives you your new. You can do that like a little fact family. Well, my original is 6.3. My scale factor is 1/2, so I'm going to take 6.3 and multiply by 1/2. That's going to give me my new length. I know what you guys are probably going to want to do. You're going to want to take 6.3 and not multiply by 1/2. You're going to want to change it to 0.5. Yep, that's how you're going to get your answer. Scale factor is a number you multiply to change your original lengths into your new lengths. And this gets you halfway through review number 2.